And it's all yours, Barry.
Right, awesome. All right. So this next section is one of the adjustments that was added from the original, which is on authoritative DNS. And what I'm going to do to kind of kick things off is I'm going to share, and make sure optimize for sound as we share this, because I'm going to share a YouTube video which is to me one of the great YouTube videos of explaining our problem with DNS in the world. So now, pardon for people who don't speak Japanese. I don't speak Japanese, but it's got the subtitles in it. So you just kind of listen through with it.
ところでお前の会社って何やってんだっけ？ああ、JPRS はサイトやメールのアドレスに使われる .jp ドメインの登録や管理をしているんだ。ドメインっていうのは最後の文字列の種類がいろいろあって、日本のドメイン .jp を管理しているのが JPRS なんです。.jp のつくアドレスでネットが見られたりメールが送れるのは JPRS が24時間365日 .jp のサーバーを管理しているからなんです。あれ？もしもし。
ちょっとよろしいですか？旦那様が眠らなくなってもう3年になります。それではお願いいたします。
.jp は世界で一番安全な国別ドメインに選ばれていて、登録数も120万件を突破しています。ちなみになぜ .jp が安全かというと、 DNS サーバーの設定を定期的にチェックし、危険性を排除するために不適切な設定を削除。
眠ってしまうほど小難しい話ですが、とっても大切な仕事です。.jp を通してインターネットの基盤を支え、今日もあなたと世界をつないでいます。 JPRS。
ところでお前の会社って何やってんだっけ？
So that's kind of like indication of us in the world with DNS as an afterthought. So we're going to be talking about the DNS risk assessment, what's going on with the miscreants are doing with DNS, and that was actually a commercial on TV in Japan. So it's really good that they saved that. You know, it's kind of like it's on YouTube, and if you're ever interested in using it as a example to your bosses about, hey, we can't neglect our DNS infrastructure. You know, here I'll drop it into the chat so you can like it and use it and download it. I've used it at times too, because people go like, what, DNS? Why do we need to worry about DNS? Because you can really take it out. Because what happens with DNS is, one, they think DNS is one thing. One of the big problems I run into organizations is they think DNS is like, oh, it's all DNS. I go, what part of DNS? There's the DNS that is your root architecture. There's a DNS, which is a top-level domain architecture with the registry, and top-level domain with the registrar. Then your actual authoritative infrastructures, right? So each of these are different architectures, different how you actually build resiliency around it. Then you have the DNS Resolver infrastructure, like inside of an ISP or in the cloud. Then you have what happens in the house or in the home or the enterprise. Right? This all kind of works together, and it all impacts all the services you run out there. And, you know, I don't know if people have looked at it recently, but you pop up a typical web page and you look at the amount of DNS transactions that goes on, because it's not just the DNS, it's not just the objects that you see on the web page. There's all these other objects that get placed in for like tracking your whereabouts and what's going on with it. And all that is critical. And it becomes even more critical as we move to this meta universe, because part of the meta universe is taking the virtual world and link it to the real world with augmented reality. And when we get functional glasses, you know, I live in Cupertino right now, so I got friends who are working on the Apple and the Google glasses. And you do things like you turn your head and you got all this object, and you look at I look at the PCAPs of the DNS, I go like, holy cow. There's like a huge amount of transactions. It's all got to work. And it's all a critical dependency because those glasses, the VR, the augmented reality, doesn't work unless the DNS works, right? So this whole infrastructure that we have to look at, we can't neglect. It's a critical dependency out there, and the attackers know it. They go after it. So as I mentioned before, the reason why dropping this session in here versus doing it as a separate module is because over the last few days, the different forms of miscreants, whether they're state-controlled or affiliates or allies, because in state, in a cyber war, you have the state actors, right, who actually work for the government. You have the contractors who are affiliates working for them, and then you have the allies, which are like, hey, I want to do my part. They're not really controlled by the state, but they'll do nonsense out there. So when you look out of it, they're poking at name servers, they're poking at DNS, and they take it down, and it doesn't work for a while, and then it goes back up, and then they'll hit it again. So this is hidden infrastructure. DDoS extortion attacks, they go after DNS, as I mentioned before. So let's walk through what the miscreants know, right? The miscreants know this playbook, right? They know they can go after the authoritative DNS, and they know a lot of organizations, their authoritative DNS are neglected. It's an afterthought. They do all these other fancy investments in the infrastructure. They got big fancy firewalls, but the authoritative DNS is not invested in, right? So that's our problem set. So let's take some of the typical examples out there. I put all my authoritative DNS in my data center, and I put it all behind a firewall, because a firewall is a great tool to protect my DNS. And you got firewall vendors who advocate we can protect this. No, firewall's job is to be a firewall, right? If you know how to poke a firewall with a DOS attack, with a state level DOS attack, the firewall will do its job. It will stop, it will block, all right? So a firewall is a security device that's designed to, when it functions properly, if there's miscreant traffic, you stop it, right? And if you close down the link, that's why they call it a firewall. That's what a firewall does. Keep a fire from spreading from one room to the next room. That's what a firewall does. And that's what a firewall device in the network does. And a miscreant will poke at it, and all of a sudden DNS doesn't work. Or they poke at one router. We've seen large organizations over the years, and they have the authoritative DNS behind one router. You take out the router, everything goes down, right? We've seen attackers where they used, and those of you who are service providers, we have some big service providers in Asia whose CPE devices are controlled by bad guys. In other words, people in the homes, because they've never bothered to actually lock down and secure the CPE devices that they deploy at home. As soon as you get a new customer, they put the CPE deployed, and the bad guys go out there and they scan it, and they put their own code in, and then the way they go, it becomes a miscreant proxy device. And with these miscreant proxy devices, they use to target authoritative DNS and other targets out there as part of a DDoS attack. And one of the tools they use is let's hit the authoritative DNS with what we call a pseudo-random domain attack, and overload the capacity, the computational capacity, the DNS query capacity of the authoritative server. We've seen, like with the sea turtle attacks, where the registrar, the people who control and access, whether I go to GoDaddy or Namecheap or whatever registrar I use, and their credentials get popped. You get a phishing attack go in, and ransomware crews are doing this sort of thing. They're looking, they get in as a ransomware phish, they start poking around the network, moving laterally across the network. So remember that first session we did was on ransomware. Well, one of the things they do laterally is they go out there and say, okay, here, who is in charge of the DNS? All right, it's these people, because their names are published there. Here are the people in charge. Oh, let's go, once I break in, let's go find them. Or if I break in, let me go look them up and I find who I'm supposed to target. And then I get their credentials, right? And then once I have their credentials, I have control. I can do interesting things with the registrar control. Like in the sea turtle attack, they got into the system, got into the registrar, and then they, in the middle of the night when everybody was asleep, they went in and registered valid certificates, right? So they registered valid, TLS certificates, and then they reset everything. And then in the middle of the day, they put a big man in the middle, and they captured a whole bunch of stuff off the corporate network because the certificates are valid certificates, right? So all these examples, were because nobody thought that people would attack the router supports DNS. Nobody thought that, you know, we'd get reflection from CPEs who are supposed to be valid, right? They you know, why would somebody do that? Nobody thought that you would have a spear phishing attack that led to a big break-in, right? DNS was all an afterthought, and that's our problem, right? So this is what we're trying to address. People get distracted because they think it's all about the reflection attack. Now, what's interesting when we were looking at the cyber green statistics, this is a cyber green statistic from, this is old, 2007, 2017, 2018. 2017, 2018, the DDoS resolvers, I mean, the DNS resolvers were the big reflector source. Today, the big reflector source is NTP. It's shifted because people have been doing things in the industry to plug the holes, right? But people think that, oh, wow, I just need to worry about reflection attacks. That's my risk. And it's not that way. People are failure imagination. I'll go back to that slide, right? And the illustration I gave here is, you know, if I was an attacker out there, you know, I'd go out there and overload the authoritative DNS. I'd overload the origin, right? So that's the attack types, right? I mean, the sort of things it can go after out there. So let's talk about DNS attack types, right? So DNS attack types, you get reflective attacks that bounce off of infrastructure. You get volumetric attacks. You'll get state attacks, which are valid packets, but when you connect up, you'll get back-end processing because the DNS server, you send it a query, and then you got to do a lookup. So there's a two-step process. You're asking a question and you're getting a response, right? So if you lock up the response, where the response has to do more work, those are the types of state attacks. You'll get malformed packets. You'll get penetration getting into the system. Like a lot of times the authoritative DNS, I remember when, let's see. So the mobile operator I mentioned when I went in Indonesia, I got in there and I got into the network at night. I was checking around, and we have DNS functions inside of a 3G, 4G network. And I connect up to the device, and there's the password prompt. And I press enter, and the password got me in. What? I said, why are we? Why do we have like basically anybody can access? Oh, but nobody would do this. Like, okay, I'm doing it. Okay, you know, people will break into devices. So all the different security sort of things you have to do to protect any sort of device in your network, you have to do on your DNS infrastructure. And a lot of times people forget that, and it's weak. And, you know, if a bad guy gets in, you know, APT ransomware, you know, break into the network, this is a form of attack, right? So that goes through it. And then BGP hijacks. I'm not talking during this APRICOT a lot about BGP hijacks and BGP route security and things like that, because we actually got parallel sessions, tutorials, or we got others out there covering a lot of that topic area. So that's not, we're not covering a lot of that in detail. We got others who are doing that. So that's good. So what we're going to go through is we're going to walk through several of these attack vectors. So that way you can kind of conceptualize and see. And then you can imagine using this presentation with your management to say, this is why we actually need to pay attention to our authoritative DNS or our resolver DNS, depending on the situation, to actually build up and beef up the resiliency of those as part of our DDoS protection and our capability for it. So let's go through like one of them, a phantom domain. So a phantom domain attack, right, goes after the resolver and goes after the organization. And phantom domain is a type of phishing. So I set up a fake authoritative server, and I'll go out there with a fish, and people will connect up to it, right? So we can see these with, you know, this is where the DNS Resolver as a security tool will look for these newly created domains and how they're used, right? So now these fake domains can actually be used as a DOS because it can overload the DNS Resolver too. So we've seen those sort of things where miscreant will either misconfigure because they won't know how they're setting up the fish properly, or they will intentionally, because they're trying to overload the DNS Resolver to get people to not use it, you know, bypass it. So how do you make sure you work around this? Turn your DNS Resolver into a security tool, right? That's key thing. When this is like, you know, if you're not familiar with this, let me know. We set up other sessions with it, because turning your DNS resolver into a security tool where it's checking the domain names against a list of, cloud security intelligence. There's a whole bunch of feeds out there. When we talk about a session tomorrow on building community, I'll point to a whole bunch of free feeds you can actually pull and integrate into a open source DNS resolver to do this. So this is kind of like key with it. NX domains. NX domains is a query for a record in a zone that doesn't exist. So that's what an NX domain does. And what will happen is the attacker will set up malware inside the organization and then use the NX domain to actually overload the authoritative server. So this is going after the overloading the DNS resolver, right? And the DNS resolver is trying to go to like a bank, so bank.com, right? And what you're doing is you get the authority, you send a NX domain over and over and over again, where that DNS resolver going to the bank authoritative server, the authoritative services, that resolver is bad. I'm going to block it. So then, then it's blocked. And now that resolver can't resolve bank.com. And then the miscreant can do that as a form of we see these as supply chain attacks. So in other words, this would be like a supplier of parts to another organization. And that's what I've seen this attack vector. They also use NX domains as reflectors. So here they go to a bunch of open resolvers and they'll set up NX domain attacks where they reflect through it. And so you get a saturation of NX domains in the authoritative server. So this is a type of when you get like a DNS reflection attack, I get this all the time. People say, oh, they're attacking with a DDoS with DNS reflectors. I said, okay, but what type of attack is it? Well, what do you mean? Is it an NX domain attack? Is it just a packet flood? Are they what's going on with it? Are there valid queries? If it is a valid query for NX domains, what domains are they using? Are they using the same ones? Right. So this becomes part of the intelligence of understanding, the differentiation between the type of attack vector that's being used, and the attack vector can tell you things. Now, one of the ways of getting around this, I just dropped this in here, is you can work around this by pushing up to the cloud. This is one of the reasons why you get so many organizations, you get it off your data center, you use one of the cloud services, and then push it up to the cloud, and it vastly mitigates these sort of nonsense attacks out there. It adds a lot of resiliency because it makes it harder for the attacker. So remember, the first day, principles of the miscreant. Number one, don't get caught. Number two, don't work too hard. So remember, using behavior approaches to actually build resiliency to your system. So you take your authoritative DNS and you move where you take the servers you have, you turn them into hidden primaries on the data center, and you push all the name servers where they're secondaries in the cloud, and you just made it harder to do it. What's going to happen? The bad guy's going to go somewhere else, right? So this is an example of that. The pseudo random domain attack is where I'm using carrier infrastructure. I'm actually using the carrier CPEs broken into, so they look legitimate, but then I'm trying to overload a target. And we've seen major carriers in the world over the last 15 years where their CPEs get infected and the bad guys take over. And then, sometimes it becomes difficult. There's one carrier in Europe who is trying to clean things up, get the bad guys off their customer CPEs. And the bad guys got mad because they were using the CPEs as a DOS as a service, right? You call them up and they do a DOS as a criminal activity. And when the carrier was trying to clean them up, the bad guys decided to attack the carrier. So fine, all right. Now, instead of, if you try to touch this, we will go after you. We will retaliate because now you're getting in the way of my criminal enterprise. And, just like in the movies with mob bosses and stuff like that and drug gangs, that's the sort of behavior you see with criminal behavior. If you're starting to go out there and disrupt their money, they get mad at you and they retaliate against you. It's one of the things that kind of think through with it. State lockup is where I go through and I try to overload. Sometimes authoritative infrastructure, you get so complacent because it's UDP. And UDP is an easier scaling protocol than TCP. Very simple. UDP, one packet. TCP, three-step handshake with state maintenance, right? So, you know, it's just the move from UDP to TCP is a factor larger in how you do your calculations for your size and the capacity. So you can go through and bad guy can set up an attack against an authoritative server where they're trying to force everything into TCP mode. Because if UDP doesn't work, the resolver will go to TCP mode, right? That's part of the spec. So you force it and you got everything in TCP, but then the authoritative server isn't used to that load at TCP. And now you got a DOS attack. And it doesn't fill up the bandwidth because what you're trying to do is overload the authoritative server. So your DDoS tools may not even show you that you got a DOS attack because the level of TCP load against authoritative server is probably going to be much, much less than any of your bandwidth. So if you got like, you know, NetFlow tools looking for like a spike of activity, you know, you may be going like, okay, why is the system so slow? Everything's slow. Everybody's complaining so slow. Do I got a DOS attack? No, none of my alarms on. But then you go finally look at the authoritative server. You go like, holy cow, the thing spiked up at 100%. Look at this. The state table is overloaded. I got a bunch of junk going after this thing. Okay, I got a DOS attack going on. See, it's volumetric to the point of view of that device, not the bandwidth, right? From a DDoS perspective, right? So when you get these big DDoS amplification and reflection sort of attacks, whether it's NX domains and others, you know, yes, they can fill up the bandwidth, but if you craft them properly and you point them at a particular device, that device will then have to respond and you overload it and you don't fill up the bandwidth. So you find these sort of volumetric, you know, the level of skills, right? A not skilled DOS attacker, miscreant, will just flood the bandwidth. A skilled attacker will use the same resources and craft the packets in such a way to overload the target of what they're trying to take out and not fill up the bandwidth, right? So you get this level of competency. So remember what we talked about with the New Zealand case. That threat actor was doing tricks like that. They weren't filling up the bandwidth. They were actually tuning the attack and not having the bandwidth fill, but they were actually, you know, at times they filled the bandwidth, but most of the time they were staying where, you know, hitting the particular target, right? DNS tunneling and data exfiltration happens inside the enterprise. You get a bad guy, they get inside the network and they'll exfiltrate the data using DNS because, hey, it's DNS Resolver. I got lots of DNS Resolver traffic. You look into the DNS Resolver side, what happens is you put a fake DNS authoritative server out there. So I knew this was a exfiltration technique, right, for you know, getting data out. Like a bad guy would break in, advanced persistent threat actor would get into our organization and they exfiltrate, you know, binaries and things like that. Then I go to a mobile operator in Indonesia. Then it's like all over the place because people would use this to bypass the billing mechanism and they get free internet off of it. So they get free mobile internet. It was all over the place. It was fraud, lots and lots of fraud. So you get into the mobile operator space, this technique is just like all over the place. So, you know, my security people were spinning up the whole thing about, you know, oh, this is a big problem. And the vendor was useless. The vendor had no idea what to do. So a lot of times, you know, people say, ask the vendor, no, not know what to do. So we sat down with the team and we started dropping in NetFlow and looking for all these authoritative infrastructure out there, you know, based off of NetFlow records, because they were bypassing the DNS resolver functions, right? So this exfiltration does happen. A lot happening out there, right? So when you look at this was a nice little like flow through when people say, oh, the DNS resolver is just like, not an important security tool, this is on data exfiltration as a threat model with ransomware, right? Is that, the resolver plays a role as you go through the different initial footholds, the propagation as they move through the network. And then the last part, the exfiltration, is where they're trying to get data out of the organization. So that resolver inside your organization, if you go through and say, I force everybody in my organization to use my DNS resolver. So I block all DNS resolution unless you go through my resolver. This is one of the reasons why you would do something like that, right? So that's on the data exfiltration part, all right? So malformed packets are less of a problem these days for if you got organizations who are smart. Because if you're doing organizations that are smart and you got software, the people who maintain software, you have big fuzzing architectures. Like for instance, at Akamai, we kind of review, we got a huge fuzzing and integrity check whenever we come out with new code, because it's all our code. We don't use others' code. And we know, say, here's all the packet types. So there's a lot of like checks to say, here is the known packet types. And DNS is easier to do that because your known packet types are more limited, right? We kind of know how DNS works. We have a long, long history of how DNS works. We know here's valid packets and invalid packets, and here's how we process them. So this is less of a problem these days, but they still could happen. It's one of the things to talk about, are people testing for this in the code? And every now and then, maybe once every couple of years, you'll find one of the open source implementations, they'll run into one of these and then they get fixed, right? Sort of thing. The community jumps on it a lot. And I'll point out to the community to plug into it. DNS cache poison attacks. Oh, this is a pet peeve for me because people made a big thing about DNS cache poison attacks. But these things, the way it works is I got my DNS resolver. So here's how DNS cache poison works. It's an attack on the resolver because what I'm trying to do is I'm trying to go to the users who go through that resolver, who goes to an organization. So for instance, if I want to, all these customers go through the resolver to get to a bank. And what I'm trying to do is take that bank and put my DNS server in the loop as authoritative versus the original server, so I can actually do a man in the middle, right? So that's a scenario for DNS poison. Now, the way I would do it is I have to send in a query inside the organization into the resolver and time that in such a way that as soon as the query hits the DNS resolver, I flood the DNS resolver with fake, results. So what I do is I got a race condition. The DNS resolver sends to the official one, the official name server, bank.com, right? And I'm sending my fakes in there. I'm trying to guess. I'm trying to guess the sequence number and running through thousands and thousands of queries with it to get it in there. And I slip it in. And God bless his soul, Dan Kaminsky came up with a little bit easier technique of doing that. It was a little bit easier, right? To do that. All right. So you didn't have to send 100,000 queries. You can send 10,000 queries. Remember what I just said. Instead of sending 100,000 queries, you send in 10,000 queries. You're still sending 10,000 queries. All 10,000 queries that fail get an ICMP port unreachable sent back to the valid authoritative because I'm sending in spoof from the authoritative, right? So what happens with this, I get all these ICMP port unreachables. So when a poison happens, it's really, really noisy, right? And people who deploy the Kaminsky fix, now you're back up to 100,000. So when people say, I'm really worried about DNS poison attacks, I go like, okay, just run NetFlow on your authoritative server and you flag it. And then you will know that somebody is actually targeting a DNS resolver in this company or this ISP trying to actually pretend to be you, right? It's not universal, right? So the threat to bank.com is very limited to that DNS Resolver and the people behind that DNS Resolver. So that's why this, a lot of times DNS poison attacks get so overblown because they think it's like big attacks against a bank.com, but it's not. And they think it's hard to spot, but it's really easy to spot. You just look for the backscatter. The ICMP port unreachable is coming back from, I send a packet in, it's invalid, port unreachable goes back to the authoritative. That's called backscatter. So you get this backscatter noise going on all over the place, right? So that's why the poison attacks with it. People kind of overblown it. Now people say, I do want to have resilience out there. Why don't I use DNSSEC, right? Problem with DNSSEC is that you got a dependency. The dependency is I can deploy DNSSEC on my authoritative. I go from my root to my com to example.com, and I can set that up. I have control. I have control over that as an organization. I don't have any control over the DNS resolvers turning on to ask the question, do you do DNSSEC, right? To send the DS bit over and say, give me the DNSSEC information coming over in the DNS query, right? And because people don't turn on DNSSEC, the DNS resolver could ask the question, but then don't comply, right? So if the DNSSEC is invalid, it would just keep on serving it, right? So you'll find both of those cases. So until the authoritative infrastructure does that, we got a problem with it. Registrar hijack controls. I mentioned this before with the sea turtle attack. What's nice about this is this threat vector going after the registrars, getting into the registrars. What happened when sea turtle came out was people said, oh, use the best common practices from ICANN. And then I went, oh, okay, let me pull the ICANN documents for best common practices down. And I pull out the ICANN documents and I go like, where's the best common practice? This is like a whole bunch of like, remember I told you about, with national CSIRTs, they're very eager to help you with best common practices and they overload you. And that's exactly what ICANN's the security group did, is they overloaded you. I'm scratching my head. And I know DNS and DNS security. I can't make heads or tails out of this. And I was going to point people who are anxious and worried about the attack vector to the ICANN document. I was like, this ain't going to work. We need to simplify it. So what we did is I grabbed all my DNS buddy friends inside Akamai, and we came up with this document. And we shared this document around with our peers in the DNS Over community. And then CISA uses this and everybody else uses this. So when you look at, let me just jump back here. So when you click on this, I'll jump out this so you can see this. So this is a guide that you can actually walk through. And I'll put the link out there into the chat so you can see the link into it. And let me drop this out here. And this is kind of like generic. So this is designed to be, helping, here's the different spear phishing, the registrar attacks, zone controls, and it walks you through, here's the things you should do. And this is all based off, you see here, ICANN Security Stability Advisory Committee, right? So it's all pulling from that and from DNS Operations and the DNS Org community, right? So this is kind of like simplifying those recommendations in this thing here. So this is part of your playbook on DNS, is walk people through these sort of steps. So it simplifies, here's this. So all of this would be listed out in like, 50 pages of like NIST documentation or something. And we simplified it here so you can quickly go through this and walk through this. And it kind of walks through these steps here. And every organization, because you got a connection to a DNS registrar, right? This is the sort of things you should be checking all the time with it. Like for instance, you go to Akamai. Akamai doesn't have names. We use roles, right? So we have an administrator role. And then we have several people who have access to the administrator role, and that's all set up with private keys and things like that. So that's all that's part of the recommendations. And a lot of people don't know that, I didn't know I needed to do that. Well, and they didn't know the sea turtle attack was capable. And state actors know how to do this stuff. And because of the ability to fish into an organization and get ransomware APT, this is one of the APT targets, right? So that's why you want to pay attention to this. DNS infrastructure gets hijacked. We got other sessions in APRICOT. We'll talk through this, but as we build out the DDoS resiliency architecture work, we'll be talking more about, the DNS, making sure your BGP infrastructure is set up to be resilient to hijacks and alarm you on hijacks. The way we're doing things today is you set up RPKI, which APRICOT APNIC is very big on helping to promote out there. The manners campaign, right, which we talked about yesterday. There is a technique called peer lock, which was pre-RPKI approach that Josh Schneider kind of like pioneered to set up where you have tighter agreements, right, with how you're doing your peering agreements, and then your basic BGP best common practices. So you start with the best common practices, then you say, okay, let me get the peer locks, let me be manners compliant, and then I get my RPKI set up. You work it in that order, right? Because state actors, we're seeing people with the state actor activity doing BGP nonsense. We're going to find out if the RPKI stuff and the peer lock and everything we talked about here is going to work effectively, because we're seeing attempted hijacks going on with this nation state activity going out there, because nation states do use these sort of things out there. So we get the alarms out there. It's like our organization in Akamai, we have all these alarms to watch BGP nonsense, right? So we're watching. Oh, here's a route from a region that gets if somebody tries to hijack it, we pull the region offline, right? That's part of our operational practices. So we're watching this stuff all the time. And it's something that other organizations could do the same. Manners we talked about yesterday, right? So we got, being manners compliant is one of the things to talk about is to make sure whoever you work with. So if you're going to a authoritative cloud provider, right, then you want to say, are you doing manners compliance, right? Because this is part of the actions they do to make sure the BGP part of their authoritative cloud is actually being monitored and checked and things like that with it, right? So that's a summary of the different DNS attacks and things going on with it. But then the next question people would ask, we're doing this DNS encryption now. Is that going to help? Now, I love this. I do. No, if you're Bart Simpsons, it's like, okay, not really. It makes things more complicated. I remember early on with the IETF work, we had this big panel session about 4 years ago in Montreal, and I'm bringing up the question, what are you going to do when you got every app on your phone doing their own DNS over HTTPS connection? How are you going to respond when I got a hurricane or a tornado or earthquake and a fiber cut or a volcano eruption? We're going to have a session next week on, disaster issues, right? Right. So how do you troubleshoot when, the phone's out there and people shouted me down? That was never going to happen. But what do I see today? Watch next week. Next week, there's a session where you have game companies who are using the edge and setting up DOS servers behind the edge, right? So they're taking typical, CDN edge services, they put a DOS behind it so they can make sure that the game app on the phone does not use the DNS from the mobile operator, because the DNS from the mobile operator is too slow and impacts the gaming experience, and they're bypassing it. So we're going to have, this is the world we're going to live in. You're going to have, your device, your phone, right, is going to have, within a year, if you're in Asia, because of all the games and things like that, if you've got several games out there, every single game is going to have their own DOS connection. Welcome to our new world, right? So encryption, started with the DNS privacy part, right? Let's encrypt it. That evolved into doing things with TLS. So notice it's between the user and the resolver, right? So this is the connection part. So this is a part that's monitoring with it. And I always scratch my head, said like, but who controls the resolver? Oh, and then people sidestep it. So is your point of trust like somebody doing a wiretap inside of an ISP, or your trust is who controls the resolver, right? So this is eventually evolved into the DNS over HTTPS, right? Which we're going out and doing lots of deployment out there. But this is the side it protects. It's not the resolver to the authoritative. People are talking about the resolver with the authoritative, but then people are asking, but why are we encrypting? This is public information. The zone information is public. Well, I don't know if you want people to know that this resolver is actually making these requests. I go like, but the resolvers, that's their job. They're going to make all sorts of requests. They make thousands and thousands of requests a second to all sorts of authoritative servers all over the place. And you want to go from a UDP scaling to TCP TLS, all right? And that's where the debate is going on. This is one of the things that I'll point out in a minute of where everybody here needs to kind of keep an eye on things. And luckily, you're all in the Asia Pacific region, and APNIC has been doing a really good job of keeping everybody in the industry in Asia Pacific region informed over what's happening with this. So you watch the sessions with this. So scaling is the challenge. Moving from the UDP to a HTTPS TLS is going to be an interesting thing where your resolvers have to upgrade, right? And then if we move the authoritative over, then all those authoritatives are going to have to upgrade too. It's going to be a challenge in the industry, right? So what is the community to plug into? So I'll finish up here before we get to Q&A to plug in the community. We got good DNS communities. So in other words, what I say here, you can plug into stuff. DNS ORIC, number one. So DNS ORIC is kind of like our operational point for all the DNS activity. It operates as our DNS emergency response team, as an operations team. Everybody who writes DNS code is on that team. They had their meeting last week. The videos are public, so you can watch it on YouTube. You go to DNS ORIC, you look at the meeting. You can watch very interesting, geeky DNS meetings as geeks talk to each other. A lot of the people who participate, you can email with and say, hey, I watched your video. I didn't understand what you were saying. And you can correspond. There's a lot of correspondence that happens. They have a Mattermost system set up so you can join as a member, or if you're not a member, you can be affiliate and go into the community and ask lots of DNS questions. So this is the way you get your DNS operations team plugged in, right, to that community with it. There are a couple of core mailing lists to sign up to. There's sign up to the DNS operations. If you do anything with DNS operations, if your operational system, sign up to that. If something happens of DNS in the world, some crisis, some tool, something going on, that list is the list. That's our DNS crisis point for the entire industry. And anybody here can sign up for that. Now, parallel to this, and I'll talk about this in a minute, EDDI, another list to sign up to. So you have this link in here that you can sign up to, right? And I'll talk about that in a minute. DNS Viz is another tool, the bookmark. DNS Viz is a great tool for testing when you are deploying DNSSEC to make sure DNSSEC is working properly, that all the chain of trust is working appropriately with it. So we maintain this in the industry as a tool. Every other week I'm helping a customer get their DNSSEC deployed, and I use DNS Viz and show the customer, here's how you can use this to test, make sure everything's working okay. We got great work out of APNIC. APNIC Labs has got some really good studies and tools out there. So as I said, thanks to their work on there. So one of the tools I point to for the industry is how much DNSSEC is deployed. Well, APNIC's lab is measuring that, right? So this is something as a benefit in the region, in the APRICOT region, check out the APNIC Labs report on DNSSEC. And then there is this group. I put this at the last. I put the link in there to sign up to the mailing list. But EDDI is interesting because I mentioned that conversation I had at IETF. And IETF got really weird post Snowden about encryption. And a lot of they just lost some operational context. And in losing the operational context, operators got together and says, look, we're worried about what was going on at IETF. Let's go back. So we need to create our own group to make sure that we don't have the IETF screw up the internet, just plain up, which is really weird to say, but that was the concern of why the EDDI group was created. Now, signing up to this is very, very useful. Even if you sign up to the mailing list, I sign up to it. They have meetings every week. So every week they actually get together and they're talking about operational deployment. Like you've seen this stuff with the Apple Private Relay. You've seen stuff with Google rollouts. You've seen as different operators are rolling out their DNS encryption architectures, in the privacy architectures, this is the forum where everybody's talking about the rollout to make sure we don't make a mistake, because DNS is critical. It's critical to what we do with it. So you sign up to this. And if you don't attend the meetings, you get the emails and pointers, and all the meetings are recorded. So everybody here who's in Asia Pacific time zone, the meetings are more European, East Coast, United States centric in the timing of the meetings. But they're all recorded, so you can pop up and listen to the recording if you're interested. But you get every week a whole bunch of list of look at these different news articles. You get the development of it. So if you're really interested about what's going on with DNS encryption, go here, sign up. Everybody here can sign up for it, especially if you're operator. All the operators are encouraged to sign up to this. They have a whole bunch of work streams on GitHub. So when you get these slides, you can click on the links and drop it into there. So that's DNS. Let's not make it into an afterthought. We're at the top of the hour, so we finished just in time. And let's do some Q&A. Let's see what questions we got from people. Okay, so Anand, what are the options available for DNS resiliency for ccTLD to function properly in the event of submarine cable link fails? It becomes isolated for a geographic region which does not manage any root servers, but only so this is I think the way to show it, give me a second with that, is I'm going to pull up a slide that I use. And this is actually a slide from Apologies. It's a vendor slide. It's an Akamai slide deck. But this is similar to extortion attacks. Is what we got is like, I call it now the Facebook problem. Okay. So the Facebook problem is, you notice that Facebook had a big outage because all their DNS was behind their infrastructure. Let me drop this off like this and do slideshow. So here you have, and we had DDoS. We had this one fancy Lazarus DDoS crew last June go after service providers. And what they do is they go after the authoritative infrastructure inside the autonomous system. So in this case, you're asking about with ccTLD, right? Now, you can have a fiber cut. This could be a fiber cut issue, right? And the problem is when these are taken out, whether it's a fiber cut or it's a DDoS attack, right? You're stuck if it's all within your realm of control. You need to put some things outside your realm of control, right? So the old practice is to put DNS secondaries in different parts of the world. Now for ccTLDs, you'll have like PCH. It used to be several groups. Dyn would do it, ISCs, SNS would do it, and PCH would do it. So as a ccTLD doesn't have a lot of money, this is a country code TLD, you would go to PCH and ISC and Dyn, and you'll get, there's your coverage. And you'd have these servers outside of your realm, like, or your country or something. So it would still be functional. It would be functional inside the country and outside the country. And then you have to come up with contingency plans. How do I update the zones if out of band, right? Because in band, the internet's down and I got to do out of band. So you have an out of band update plan. But Dyn doesn't exist anymore. ISC's SNS doesn't exist anymore. So now you just got PCH, right? And for some of the service providers, PCH isn't enough. And so that's where they come up with this model where they go and say, okay, let's set these up, with other operators out there. And that's where they were knocking on the door with this. Now, if Facebook had something like this, the outage that they had with BGP wouldn't have taken out Facebook. Just straight up, and they recognize it too. If you have like a CCD, the cable cut outage, right? It's same sort of stuff. So this is where this, it's good for DDoS resiliency, but as I mentioned before, sometimes DDoS resiliency and entire system resiliency all goes together. So that's a good question, Anand. Shop around. There's a bunch of different organizations that you can look at. Most ccTLDs, PCH is the first one you talk to, and then there are many others out there. Second question, do you think all the ISPs deploy their DNSSEC on their DNS resolvers? No, not at all. And thanks to APNIC Labs, you have the data to show it, right? Because that's part of the work with the APNIC Labs is you can get that sort of detail. So, any other questions? And since here's the link to APNIC Labs on DNSSEC. So if you go to that site now, remove that comma there. Let me share that so people can see that. I like to show off their work because I use it, just like you're asking that question. So here's, they got a nice color map with it, right? And they say, they break down by major of the world, who's doing DNSSEC, and then here's even smaller code, and then you can say, okay, how many people in, with Fiji, DNS resolvers doing DNSSEC validation? Oh, there's a lot there. But then you go down to like, others who are like, not doing much of anything, right? So you get this nice little statistics with it, and you can play around with it, so benefit in the region, tap into that. Next question is, do you think the client subnet EDNS will eventually die in CDN players? No. I think what happens with DoH is it will become even more prevalent. So one, people have this FUD, fear, uncertainty, whatever, that it's a security problem. It's not a security problem. EDNS zero client subnet is where the resolver sends the authoritative the aggregate IP address. But in other words, if I'm in a /24, it sends a /24 up. So that way it makes it easier to do a map-in decision into an edge service entry point, right? People call it CDNs, but it's an edge service entry point. As we get more and more things pushed to the edge, including 5G pushed to the edge, you need that service entry hint. But people say, oh, it's a security problem. I can use it to find out where the customer's at. They go like, oh, wait a minute. Okay, if I'm pointing you to an edge service point, the next thing that happens in the sequence of the signal flow is you have a connection to the service point. Now I know exactly where you're at. And I'm negotiating encryption because it's an HTTPS connection. Okay, the security is where, right? Step one is I give a hint with EDNS zero client subnet. Step two is I actually do the physical connection to the service entry point, right? As we move everything to DoH, right, we're going to need that hint more and more. So I see the reverse happening. What I see on the Akamai side is I see more and more requests for EDNS zero client subnet optimization work. It's like increasing, not decreasing. So it's not going to go away because people will work past the FUD because they go like, oh, we don't like it. It's needed, it's needed in the edge world, it's needed in the 5G world. Good question. Okay, so I think we're at the end of it. Thanks everybody for coming. The next steps is, if you have more questions, connect to me. That way you get updates on when we do more of these sort of sessions after APRICOT. We got 2 more days of this, so we got more things happening. And, we'd love to see you tomorrow and, subsequently, helping you guys build up your DDoS resiliency architectures and playbooks and things like that. So we have a safer internet.
Yeah, Barry, Anurag is not letting you away. He has a follow-up question.
How will it scale up considering the fact that it still needs manual integration at various players in the industry? So actually, the only manual place where you need to integrate that I'm aware of is actually Akamai. And Akamai is fading away from manual integration. Google uses it. it's automated. I think Limelight uses it automated. So it's coming to a point where it used to be that people thought that, oh, if they were able to do this, they would actually figure out, I'll map an algorithm. But then what would happen is people like me and a couple of my colleagues, when we came into Akamai, we went like, we don't need that to figure out the mapping algorithm, right? You know, the mapping algorithm is sitting right there, right? You can just like do these sort of tests and you figure it out. So the trend is to make it easier and easier so that the resolvers that connect up to it. And so as we move to a DOE universe where DNS is part of an encryption path, we're going to need this. I think the load isn't so much on the what you're talking about, Anurag. I think the load is going to be the system load, because the people who are knocking on the door to get optimized for ENS 0 client subnet are people doing DOEs to games. I got 6 games on the mobile phone, and each one of them have their own DOE connection, and each one of them have to do, you know, ENS 0 client subnet to make sure it gets, you know, connected to the closest service entry point. Right. So that's what we're seeing is it's, I think it's going to move over a load calculation than a manual configuration. Okay, great. Thank you, everyone. And
thank you very much, Barry. That's the 3rd day. So what's that, 60% done? 40% still to go. Been quite an epic, but no, it's fascinating content. Thank you very much for that. Thank you very much for your time.
Like the old days, Philip, when we would teach it the whole week and do the whole ISP workshops, right?
Indeed. Absolutely, indeed. So thank you for that. Thank you, everyone, for joining the session. I'll just